So today we're going to look at finite differences and how to use those to determine what kind of polynomial you have. We're also going to be looking at our calculator and using our calculator to create the equations. So if you don't have your calculator out yet, go ahead and push pause and go get it. And then we're going to move on to the first one. So use finite differences. I'm going to talk about what that is, to determine the degree of the polynomial function that fits the data. When the x values in the data set are equally spaced, the differences of consecutive y values are called finite differences. So one thing that we need is the x values to be equally spaced. I feel like a lot of time they're spaced by 1, but it doesn't have to be 1, they just have to be equally spaced. So if all of my x values are separated by 2, or if they're all separated by 3, it doesn't matter as long as they are the same. Here, all of my x's are separated by 1. So now I need to look to the y values. This is where the work comes into play. I look at my y's. I'm going from 1 to 4. I am getting larger, so I'm adding. To get from 1 to 4, I have to add 3. 4 to 10, I'm adding 6. 10 to 20, I'm adding 10. 20 to 35, I'm adding 15. 35 to 56, I'm adding 21. So maybe this is the first one you weren't exactly sure right off the bat what you needed to do to get there. When you are finding the finite differences mean subtraction. So to find that, here I would have done 4 minus 1 to get 3. 10 minus 4 to get 6, 20 minus 10 to get 10, 35 minus 20 to get 15, 56 minus 35 to get 21. So those differences are found that way. 84 minus 56 is going to give us 21 or 28. What we're looking for is we're looking for all of these differences to be the same. If they're not the same, then we need to move on. So then we go, our next set here. If I'm going from 3 to 6, I'm adding 3. 3 to 10, I'm adding 4. 10 to 15, I'm adding 5. 15 to 21, I'm adding 6. 21 to 28, I'm adding 7. My differences are still not the same. They are evenly spaced, but that's not what I want. I want these numbers to be exactly the same. So I'm going to keep on going. Now my next set of differences, I'm going from 3 to 4. That's separated by 1, 1, 1, 1. Perfect. Now this is what I need. I need all of these numbers to be the same. You need to continue to find out your finite differences until they are exactly the same. So we did it the first time, it didn't work. The second time it didn't work. The third time is when it worked. That's how I know what kind of polynomial I have. If the first differences are the same, then it's a first degree polynomial, making it linear. So if it's linear, that means that the first set of differences are the same, which it's not, so it's not linear. If the second set of differences are the same, then the polynomial is second degree, making it quadratic. The second set here in red is not the same, so it's not going to be quadratic. If the third set of differences are the same, then the polynomial is cubic. That's what we have here. We have a cubic function because of the third degree it's not the same until the third time around. So we just found out that this is going to be a cubic function. And if the fourth set of differences are the same, then the polynomial is going to be a quartic function. Okay, now it's time to move on and have that calculator out. We've got calculator work coming our way. So we're going to use those finite differences again to find what kind of polynomial it is. And then, using what kind of polynomial it is, the calculator is going to tell us what equation best describes that data. So I look at my x's negative 2 to 1. I see that all of my x's are going up by 1. So remember, the x's need to be equally spaced from the beginning. And then we go to the y's. 6 to negative 21. I'm getting smaller, so I'm subtracting. And remember, if I'm going to do the differences, it's negative 21 minus 6, which gives us a negative 27. And negative 20 minus negative 21, that means I'm actually adding 1. I'm finding all of these differences. I'm adding 5 from a negative 15 to a positive 18. I'm adding 33. Remember, 18 minus a negative 15 means I'm adding 15 plus 133 plus 353. Now, if these were the same, this would be a linear function, but they're not. They're not the same, so I move on to the next set. Negative 27 to a positive 1. We are adding 28 to 1 to 5. I'm adding 4. 5 to 33. I'm adding 28. 33 to 133. I'm adding 100. 133 to 353. I'm adding 220. So I look at my second set of differences. Those are not the same. If they were, it would be quadratic, but it's not. So then we move on again. 28 to 4, I'm getting smaller. I have to subtract 24. I'm getting larger. I add 24. I'm getting larger. I have to add 72. Add 120. My third set, again, is not the same, so it's not cubic. So if I go from a negative 24 to a positive 24, I'm adding 48. I'm adding 48. I'm adding 48. Now that my fourth set of differences are the same, it's going to be a quartic graph. Now that's important because now I need to go to my calculator. What we need to do here is we have our calculator out. I'm going to hit the stat button. We haven't used the stat button yet, I don't think. So the stat button is right here. It's by the arrows. It's underneath delete. I want to edit number 1. And what that does is it lets us edit our list. Right now, you need to make sure that you have an L1 and an L2. If you don't have an L1 and an L2, it's going to get messed up. And sometimes maybe, let's say, don't put these numbers in. But if you have numbers, we can clear the whole list at once. If you arrow up and you hit highlight L1 and you hit clear, which is below the arrows, and then arrow down, it empties the entire list for you all at once, which is very useful when we enter all these data points in. Now, if I had instead hit delete, notice how my L1 disappeared. That creates a problem for us. If that ever happens, we hit stat, number 5, setup editor. We hit enter and it fixes it. We go back to stat edit and see my L1 is back. So what you're going to do is in L1, you're going to put those x values. So -2, hit enter or arrow down. -1, 0, 1, 2, 3, 4. Your calculator is doing all of the work for you. You just have to make sure you enter the numbers in correctly, because if you enter a number in incorrectly, everything is going to be wrong. So we double check our numbers, then we arrow over to L2, and then we're going to put the y values in L2. 6, -21, -20, -15, and again, we should be using a negative sign and not a subtraction sign. You double check that your numbers are correct. So we need our data in L1 and in L2. Once we have our numbers, we're going to go back to stat. This time we're going to make a calculation. So I need the next column. We're going to arrow to the right. And we're going to go down we're going to be using these regressions. Notice linear regression, quadratic regression, cubic regression, quartic regression. That's why we needed to use finite differences first. I needed to figure out which regression I needed, and we said that it was a quartic graph. So I'm going to go down to number 7, the quartic regression, hit enter, and we put our x's in list 1, correct. We put our y's in list 2, correct. Now if those weren't already list 1 and list 2, if you look above number 1, you see L1 in blue, so you have to hit second number 1, that'll give you L1. L2 is above number 2. So we hit enter, enter. Don't change the frequency list, don't change this, just go down to calculate, hit enter. And then you see the format, ax to the 4th, bx cubed, plus following that pattern. So a is the coefficient with x to the 4th. B is the coefficient with x to the 3rd, and so forth. So this is the x to the 4th, this is x cubed, this is x squared, this is, or no, sorry, to the 4th, to the 3rd, to the 2nd, to the x, to the constant, yes. Now we have to be smarter than our calculator. Anything with the e negative means 0. If you use negative 6.2, it's going to be marked wrong because you're giving it a value when there is no value. This means 0. So as we write our equation, we have y equals, that a value was 2, x to the 4th. The cubed term is 0. The squared term is 0, so I don't have a coefficient again until I get to x, plus 3x, and then our constant was negative 20. Remember, e to the negative number really means 0. All right, we are going to stop there for today.